I'm delighted to introduce Rick Anderson, the Director of Virtual Worlds at Rutgers University, Yuri Allegria, DevOps Engineer, and Camille Scala, Director of the Italian Language Program at Rutgers. They will be presenting on language learning
with Camille, Machine Learning for the Web and Canvas, presented by Dr. Camille Scala, Richard Anderson, and Yuri Allegria. We'll go over the who we are, what we do, what it is we're doing. We're going to demo this, and what we want to focus on is project next steps and the Q&A combined. We're going to give you plenty of opportunity to put questions and discussion questions into the live chat area. We'll be able to collate those, chat with you during the presentation, and then when we hit project next steps and Q&A, we'll actually do the live discussion at that point. So you'll get to see us in different phases and then the live Q&A. So this should be really exciting. Thank you.
I'm Rick Anderson, Director of Virtual Worlds and Game Research and Immersive Design. My team supports faculty and innovation by combining the ideas and the concepts with cutting-edge technologies and techniques in game design, in augmented and extended reality. We use virtual world technology. We bring the world to somebody. We take your lab and put it out into the world. And we look at innovative technologies and try to fit them and situate them into things that we can accomplish that fit on the web or get into a learning management system. So in any case, the machine learning technologies enabled us to do kind of two big areas. One is take your lab, virtualize it, and get it accessible online. And it's a pretty tough topic. So what we've done is we've created a service through teaching and learning with technology that allows us to take new media, instructional designers, and my team, Grid, and help you virtualize your lab or your tools or your techniques and get them out into the world, or virtualized enough so that in like our COVID-19 land that we can, get access to stuff that normally was in person. So I'm going to look at machine learning and the way that it's been an enabling technology and an innovative technology. So what we're going to do is we're going to talk about a project that we've done with Dr. Camille Scala, who's the director of the Italian program at Rutgers. And she's going to introduce the CAMILE project. So without further ado, here we go.
Okay. During this presentation, you're going to hear me refer to a project as CAMILE. CAMILE stands for Culturally and Emotionally Aware Machine Learning-Based Intelligent Language Acquisition with Experiential Learning. This project focuses on the development of a new method that promotes a natural and holistic approach to language acquisition by providing a full immersion hands-on experience for students. Through CAMILE, learners will be able to experience the world around them directly in the target language. What makes this application more palatable is that it also includes a game aspect that engages and stimulates learners to improve progressively. CAMILE offers the opportunity to make language acquisition more fun, interactive, and more relevant. Our application helps the instructor to create authentic assignments by having the students involved in real-life situation, which makes learning a language immediately useful and meaningful to the learner's real-life, everyday life. Furthermore, it is also able to create auto-generate assignment, and the auto-generation of assignments will be based on the detected emotion and context using machine learning and AI. Machine learning can provide a uniquely personalized learning experience and guarantee immediate feedback for students to learn without delay whether or not they have mastered the material. Moreover, this project expands the application of digital humanities to language teaching. DH is a field that has attracted a lot of attention in the last few years, especially because it provides students with some of the skills that are going to be essential for any 21st century future employee. It promotes collaboration through collaborative work and group projects. It stimulates critical thinking, encourages creativity, and highlights the importance of narrative and visual communication. However, what makes this application unique is that it can be easily adaptable to other subjects as well, such as literature and cinema studies, in addition to being a useful tool for students with disabilities. Specifically, this approach combines visuals and text-based representation of emotion in a same and gamified learning environment. Our team participated in the NSF I-Core programs at Rutgers, which helps researchers to gain some sort of knowledge of the business world. And we conducted market research with potential customers to find out what elements they would like to see in a new language app. And we narrowed them down to 5 key elements, which we have included in the product development plan. The key elements that people would like to see in a new language app are the following. Number one, easy and fast access to lessons. Users would like to have an easy access to the tool, and basically they would like to be able to access it to the different devices. So the idea is anywhere, anytime. Number two, they would like real-time feedback. Immediate AI-generated feedback supports continuous learner growth. Learner can identify where they are struggling with the material, go over and review it, and they know it immediately when they're done with the activities. Number three, AI-generated a graded assignment. AI generates assignment with randomized context, which guarantees two things. It guarantees that every time the learner logs on, he is faced with different materials. And he also guarantees that the learning tasks are leveled in response to the learner's growth. Number four, authentic and immersive experiences. The learners can take on a persona through role-playing functionality, which allows them to fully immerse themselves in the language and in the culture. So this particular element promotes cultural awareness. Number five, well-constructed game and social mechanics. The tool does employ complex social and gaming mechanics to support rigorous learning, including randomness, reward, role-playing, progress monitoring, competitive elements, and rapid pacing and feedback. We believe that all of these features guarantee a unique and rewarding experience for language learners and also make CAMILE stand out when compared to other language learning tools already available on the market. And now I will let Yuri give you a practical demonstration of what CAMILE is able to do.
Thank you, Rick and Carmela. Hi, I'm Yuri Alegria, Senior Application Developer at Game Research and Immersive Design at Continuing Studies. Now I'm going to show you a small demo of CAMILE. CAMILE is an application that detects objects in an image using machine learning technologies. It is web-based, which means can be accessed from any modern web browser. Currently, I have the application running on my iMac using Firefox browser. CAMILE is currently in a prototyping phase. The end goal of CAMILE is to create an application that facilitates the learning of a new language, Italian, using machine learning technologies. The app is also intended to be used in assignments where students, the learners, get involved in real-life situations that in turn help them learn a new language. CAMILE will also provide a unique, personalized learning experience using machine learning. Let me start with the application UI. The current interface has three panels. From left to right, we have the source panel where I'm able to select my source image. There are a couple of modes that I can use: camera mode and image sample mode. With camera mode in yellow, I'm able to take an image using my device camera. Then in gray, I have the sample image mode, which are basically a set of preset images loaded to the application. Then on the middle panel, we have a labeling section, a set of input fields, as you can see, where I will be able to type in the objects that I see in the source image. Finally, at my right, I have the results panel, where I will be able to see the results based on my labeling task. The application also contains an extra panel on the bottom of the page that will be used for object annotation. We will see that later on the demo. So what we're trying to prove on this machine learning application prototype is that given an image, a pre-trained object detection model can identify which of a known set of objects might be present on the image. CAMILE plays the role of our object detection model. Let's start with a sample image preloaded within the application. I select sample image 4. Now let me label the objects that I see on the image. Remember, the assignment is to help Camille identify the fruits and vegetables on the images. Let me start labeling only one object. I see that the image contains broccoli. Let's input that. Then I click check your answers button and let Camille do his job and verify if my input of what I saw in the image is correct. There you go. Camille tells me that the single object that I identified was correct and that she was 95% confident that the object is a broccoli. Let's choose another sample image. Let me choose sample image 1. Now, let me start to label the fruits and vegetables that I see on the image. Let's say I only identify 2 fruits on the image, banana and apple. Then let's check what Camille says. There you go. Camille also identified the 2 objects on the image, and she was 83% confident that there was a banana and 53% confident that there is an apple. Although our initial assignment with Camille was to identify fruits and vegetables on the images, we can also find out what else Camille is able to identify on an image. In a learning language assignment, for example, if I'm not able to label a particular fruit, then I can ask Camille to help me identify the names of the fruits on the image. Camille will provide information about known set of objects present on the image and their positions within the image. For this task, we will use the bottom panel of our application. With my image selected, let's click on Run and let Camille annotate the objects on the image. As you can see, she was able to identify that there was another fruit on the image, orange, and find out their corresponding positions within the image by annotating each object on a red bounding box. Another feature of our application is the ability to choose between a set of pre-trained models. A machine learning model is the output of a machine learning algorithm run on a dataset. The dataset we are using on this demo is called COCO dataset, which is a large-scale object detection, segmentation, and captioning dataset. Our models are capable of detecting 80 different object classes. So far, I have been running my demo using the default model SSDD Lite MobileNet version 2, which can be set using this drop-down menu. B1 and B2 on the names depends on the version of the TensorFlow framework used to train the model. Lite MobileNet B2 is the smallest in size and fastest in inference speed. Let's see how it works. Let's select the image again. I'm gonna take sample image 4 and I'm gonna label the object that I see, and I'm going to ask Camille what she sees as well. So we have the same result that we got on the first run, and Now let's use the bottom panel from our application to verify what Camille saw in the back end and how she annotates the objects, and using, in this case, the default model SSD Lite MobileNet version 2. So we select that and we click Run. As you can see, the Lite MobileNet V2 model ran on 114 milliseconds and detect only one object on the image, which was the broccoli, and the score matches the one that Camille told us over here on the results panel. Now let's try to use a different model with the same image. This time I'm going to choose SSD MobileNet V2. The first time we use the Lite version. The second time we're going to use just the standard version. MobileNet V2 has the highest classification accuracy. I choose version 2 and then I click Run. As you can see, this model took a little longer to predict the results. It took 132 milliseconds, but it detects more objects on the image. Besides the broccoli, it detects another instance of actually two more instances of broccoli, and it also detects that there were two instances of a carrot. Finally, I'm going to show you how the application works using a live image. Let's change the mode in our source image panel to camera mode. I allow my application to access my camera. As you can see, that's a live view of my camera that I have set up on my computer, and I have an apple, orange and a banana. Let's take a picture of it. And let's label the fruits that I see on that particular image. And let's check with Camille what she says. Camille identified that there was a banana and an orange in that image. And lastly, let me find out what other object classes Camille sees on that particular image. As you can see, Camille, besides finding the orange and banana, she thinks that there is a dining table and a cell phone on that image. And that was our demo for Camille. I hope you enjoy, and thanks for watching.
Hey. Hey, thank you very much, Yuri. So we finally made it to the live discussion, and I was looking and moderating, looking in the discussion panels and all of that. So we have some next steps for the project. We have some questions. I'm really hoping if anybody's listening that they can throw into the discussion forum or throw a live Q&A question in. But we're here. Each of us have had a chance to kind of throw some stuff out there. So I think it's discussion time. Let's get, I think, I can't tell what's exactly happening, but if Carmela and Yuri here, we can talk about what we want to do, next steps, and sort of questions that the group has. So I guess my first question to the organizers is everybody here in the room? We're live?
Yes.
Okay, cool. All right. So then, what's gone? So we did this extensive project in iCore, developing it as a product and seeing how it would fit into the world. And then Yuri has been focused on saying this technology needs to get into various environments and be able to be used and evaluated. And so we've got to the point where we have an evaluation pattern and we know where we want to go, but we're also it's really important for us to talk to other people about this, get ideas, and combine those into the project. So that's where I was sort of like, if people do want to pop a question or something into discussions, that's good. But otherwise, why don't we just get started? There are 4 next steps that are clear in the project. Custom trained data sets. There's a labeling for image hovers. There's a helper mode and explorer mode. And what I'm going to do is I'll just pose the question to the group and say what kinds of things would, and the first question would be, well, what kinds of things custom trained data sets would do for the project? And that'll sort of explain what a custom trained data set is and kind of what capabilities that would give us. So
basically, a custom trained data set deals with a defined data set of preset objects that we have identified in our models. One of the next steps in this project would be to get together some data that will allow us to identify or expand the current data set that we have. Currently, we have only 80 classes of objects. And that's why, for example, in the demo, if there is one object that the particular model is not able to identify, it won't display on the result panel.
Mm-hmm.
But if we're focusing on, for example, language learning, we will have to expand our data set so that we can cover more of the actual objects that you can see around us, around the places that we live and stuff like that. So that's one of the big challenges in the next phase. That will be the next approach.
Cool. And actually, some questions came along as you were talking, so I'm actually super excited. Let me just run those past the group. So the first question we hit was, could this be used to identify specific dishes within a cuisine? Yes. And yeah, the answer is definitely yes. And I think the custom data set question, the idea there too would be that you could think about meals versus your refrigerator. You're going to have an assignment that's about exploring what's in the refrigerator, what's in the market, or you could talk about what are you having for dinner. So, oh, Carmela?
No. Go. I was looking. I think there's another question about if this is applicable to math and physics, which is really interesting.
There are ways to do live problem posing and solving. So also there's a challenge in various mathematics when it comes to gaming. And if you use gaming to pull the math out, you're going to actually get some really interesting challenges applying math to the real world. There's simple augmented reality things that are about measurement. But if you say, well, what does measurement mean? That may give you some additional tools to work with. But I also saw some pretty cool things. One was there's a Food 101 data set. I would love to get access and incorporate something like a Food 101 data set. What that would do is it would give us more common foods to be like at the forefront of the choosing. So that would mean, more common, more, that would be more curated towards the assignment. Then overlapping objects are, sometimes overlapping is about quantity, how many things overlap, because it can recognize a group versus an individual. So that's where we got counts of carrots. So food overlapping, but there are sometimes overlapping can cause trouble, but that's I think that would get to one of our questions about assuredness. And that would be like in the helper mode that we want to do in a next step, which is that Camille will have a confidence that it's found something that matches, but it might be 90% sure or 50% sure or 20% sure. So there actually can be an explorer helper mode where you're helping Camille recognize and understand objects. We're running out of time. And then explorer mode is grab the phone and go. Be in the world.
Thank you all very much.
Thank you.
Thank you.